This lecture introduces Chapter 14, Measuring Galaxies. The learning goals are to understand the prevailing theories about the nature of the universe that were debated in the early 1900s and to understand that the Great Debate set the stage for the work of Edwin Hubble, who discovered the expansion of the universe. Charles Messier created a catalogue of large, diffuse objects that fooled comet hunters. There was growing interest in catalogues of nebula. What is the nature of the universe? Are there gas clouds within the Milky Way? Or are there island universes? In the 1920s, astronomers identified faint, fuzzy objects called nebulae in their telescopic observations. The interest in understanding where and what these objects were sparked the Great Debate. From 1902 to 1920, Curtis worked at Lick Observatory, in Santiago, Chile, surveying of nebulas. In 1912 he was elected president of the Astronomical Society of the Pacific. He investigated the then called spiral nebulas and became convinced that they were independent star systems. In 1917 he argued that the observed brightness of novae, found by him and by George Ritchie on photographs of spiral nebulae, indicated that the nebulae lay well beyond our galaxy. He also maintained that extremely bright novae, later identified as supernovae, could not be included with the novae as distance indicators. During the war years, 1917 to 1918, he organized and conducted a navigation school for the United States Shipping Board in San Diego, California, in teaching navigation in the Naval Officers School in Berkeley, and as research physicist in the optical section of the National Bureau of Standards in Washington, D.C., where for a time he was acting head of the optical section. In 1918 Curtis observed Messier 87 and was the first to notice the polar jet, which he described as a curious straight ray, apparently connected with the nucleus by a thin line of matter. In 1920 he was appointed director of the Allegheny Observatory. From his work surveying nebulas, Curtis advocated the now accepted view that other galaxies apart from the Milky Way existed. He estimated the Andromeda Nebula, now known as the Andromeda Galaxy, to be 500,000 light-years away. Many people, including Harlow Shapley, opposed this view. From 1914 to 1921, he was at Mount Wilson Observatory, where he calibrated Henrietta S. Leavitt's period luminosity relation for Cepheid variable stars and used it to determine the distances to globular clusters. He applied this calibration to determine the distances to large groups of stars called globular cluster. At that time, very little was known about the overall shape of our galaxy or our place in it, though it was presumed that the solar system was at the center. By the time he finished his research in 1919, after publishing more than 40 research papers, the overall shape of our galaxy was coming into focus, including the position of our own solar system. Shapley also proposed that the Milky Way galaxy was 300,000 light-years in diameter, far larger than previously assumed, and that the spiral nebulae lay within it. The Great Debate, given at the National Academy of Sciences on April 26, 1920, is one of the more dramatic episodes in the history of astronomy. There were oral arguments given by Curtis and Shapley, followed by extensive publications. Although Shapley's central argument was that the universe was much larger than previously thought, the debate is generally viewed as centering on whether the spiral nebulas were island universes. More specifically, Curtis argued that the Sun is at center of relatively small Milky Way because star count analysis and distance estimates from spectral types and intrinsic brightnesses of stars suggested smaller, heliocentric galaxy. He did not believe that Cepheid variables were good distance indicators. Spiral nebulae are galaxies beyond our own because novae in Milky Way similar to novae in spiral nebulae, implying very distant nebulae. He thought that Slipher's spectroscopic measurements of high recessional speeds for nebulae implied they were not galactic objects, which would be moving much more slowly relative to Sunday. He thought the apparent sizes of spiral nebulae consistent with his estimate for Milky Way when nebulae placed at extragalactic distances, and that photographs revealed absorbing material in nebulae consistent with that he thought present at galaxy's edge. He did not believe van Maanen's measurements. More specifically, Shapley argued that our Sun is far from center of galaxy because globular clusters more concentrated towards one half of sky. Variable star distances implied globular clusters in concentrated half were further away. Milky Way must be large because variable star distances implied galaxy was larger than previously supposed. This meant that the spiral nebulae, now known as galaxies, are within our galaxy because great extent of galaxy precluded spirals from being other galaxies. He further argued that van Maanen's proper motions implied spiral rotation speeds close to the speed of light. That is, distances to nebulae must be small for implied rotation to be in physically acceptable range. In summary, Shapley's research at Mount Wilson Observatory convinced him to argue that the universe is one gigantic galaxy that is 100,000 parsecs across. The Sun and Solar System are far from the center of the galaxy. Nebulas are huge clouds of gas and dust and are actually part of the Milky Way galaxy. In summary, Curtis' research at Allegheny Observatory led him to argue that the universe is made up of many galaxies. Our galaxy is smaller than Shapley suggests. It is about 10,000 parsecs. The spiral nebulas are other very distant galaxies, completely separate from the Milky Way. Shapley believed that the diameter of our galaxy was 300,000 light-years, that the Sun was not at galaxy's center, but 60,000 light-years away, and that the Milky Way was so large, it was the entire universe. He believed that the spiral nebulae were gaseous clouds repelled by Milky Way's light pressure. Curtis believed that the diameter of our galaxy was 30,000 light-years, that the Sun was very close or at center of galaxy, and that the spiral nebulae were galaxies. That is, that the spiral nebulas were island universes in their own right. Edwin Hubble, founder of observational cosmology, resolved the debate. His observations of Cepheid variable stars in the Andromeda galaxy shows that both were correct to some extent. Curtis was right about spiral nebula being very far away and being galaxies separate from the Milky Way galaxy. Shapley was right, that the Solar System is far from the center of the Milky Way galaxy. Shapley was correct that the Sun is located well off center of galaxy. Shapley was correct that the galaxy is much bigger than previously thought, although he overestimated the size. Shapley was correct that the Cepheid variables are good distance indicators. Curtis was correct that spiral nebulae are external galaxies. Curtis was correct van Maanen's results were not good. Both Curtis and Shapley were incorrect that interstellar absorption of starlight by dust was unimportant. In 1925, Curtis invented a type of film plate comparator, allowing two plates, each 8 by 10 inches, to be compared using a set of prisms and placing the plates on stacked and aligned stages rather than next to one another as was the norm. This allowed the body of the device to measure just 60 by 51 centimeters. In 1930 he accepted the directorship of the astronomical observatories of the University of Michigan. Although Professor Curtis came to Michigan prepared to design a large reflecting telescope in Ann Arbor, Michigan, by the time he completed design of the telescope, the funds were no longer available for its construction due to the Great Depression. During his lifetime, Curtis participated in 11 expeditions for the study of solar eclipses. His contributions for this impressive number are underscored by a quote from fellow astronomer Campbell at the 1900 eclipse: "We do not see how we could have dispensed with his services, nor how anyone could have met the exacting demands better than he did." After the debate, however, Shapley was hired to replace the recently deceased Edward Charles Pickering as director of the Harvard College Observatory. He hired Cecilia Payne, who, in 1925, became the first person to earn a doctorate at Radcliffe College in the field of astronomy, for work done at Harvard College Observatory. In his later years, he became a political activist during the latter New Deal and Fair Deal. He was on the original Standing Committee of the Foundation for the Study of Cycles, on the Board of Trustees of Science Service, now known as Society for Science and the Public, helped found government-funded scientific associations, including the National Science Foundation, and put the S in UNESCO, the United Nations Educational, scientific and cultural organization. Sparking controversy, Shapley was subpoenaed by the House Un-American Activities Committee for his role as member of the Independent Committee of the Arts, Sciences and Professions, major political arm of the Russophile left, for opposing U.S. Representative Joseph William Martin Jr. during midterm elections that year. In 1947, he became president of the American Association for the Advancement of Science. More controversy was sparked by his inaugural address, during which he referred to the global threat of the genius maniac and proposed the elimination of all primates that show any evidence of signs of genius or even talent, among other threats that included drugs that suppressed the desire for sex, boredom, world war with weapons of mass destruction, and plague epidemic. Never leaving his scientific work, in 1953 he proposed his liquid water belt theory, now known as the concept of a habitable zone, which we discuss in the last chapter. One of his sons, Lloyd Shapley, is mathematician and economist Lloyd Shapley, who won a Nobel Prize in Economics in 2012.
The galaxy size and shape as we know it today is pretty close to that described in the lyrics of the Galaxy song composed by Eric Idle, Monty Python's The Meaning of Life. The lyrics read: "Our galaxy itself contains 100 billion stars. It's 100,000 light-years side to side. It bulges in the middle, 16,000 light-years thick, but out by us it's just 3,000 light-years wide. With 30,000 light-years from galactic centerpoint we go round every 200 million years, and our galaxy is only one of millions, of billions, in this amazing and expanding universe.